Machines and fixtures must be controlled. For systems such as this rotary indexing machine, pneumatic and electric working elements are used. Both types of control must be linked to one another. This requires transducers. There are two kinds. One, transducers to provide the connection from the electric control circuit to the pneumatic control circuit. These are called electric-pneumatic transducers. Two, transducers that connect the pneumatic control circuit to the electric control circuit. These are called pneumatic-electric transducers. Signals are transmitted in the electric control circuit by means of switches and contactors. Switches and contactors close contacts, open contacts, or change contacts. There are a number of types of operation to execute these functions. Manual, mechanical, electrical, pneumatic. Pneumatic electric transducers, switches. An example of the operating principle of a switch. By a pneumatic signal at the connection Z to the compressed air supply, compressed air is applied to a diaphragm which operates the pushpin of an electric switch. The preload on the diaphragm causes it to act as a spring. At terminal 1, the current is fed in, and at terminal 2, taken off. If the current flow is interrupted when the switch is actuated, the switch is called a normally closed switch. If, on the other hand, the current is taken off at terminal 3, we have a normally open switch. If the current is taken off at terminal 2 or 3, we have a changeover switch. The symbol for a pneumatic electric switch. Pneumatic electric transducers, contactors. If a motor is to be switched on by a pneumatic circuit, a pneumatic electric transducer is needed. The motor contactor is actuated by means of the switch. A pneumatically operated contactor thus combines both functions in one device. This is how it is constructed. By applying compressed air to the piston via Z, the contactor picks up and closes the contacts. The return orifice check valve has two functions. On the one hand, excessively rapid closing of the electrical contacts and thus excessive bounce are prevented when the compressed air is applied. On the other hand, the compressed air can escape quickly via the check diaphragm when venting. Premature contact wear as the result of sparking is prevented by the rapid opening. This design also allows the device to be used in a reversing contactor combination. This requires the connections from P to A. When the contactor is energized, passage from P to A is blocked and A is vented. This provides the function of a 3-to-2-way valve. The symbol indicates the most important functions. The pneumatic operation, the return orifice check function, the 3-to-2-way valve, and the contact connections. For a reversing contactor combination, two contactors are necessary. Clockwise or counterclockwise operation of a motor is to be pneumatically blocked by means of interlocking. This is necessary when cutting threads, for example. This is how the control system looks. A signal E1 that is fed via P1 and A1 to Z2 energizes the contactor for clockwise operation. In doing so, the line R is connected to the motor connection U, S is connected to V, and T is connected to W. Simultaneously, the contactor blocks passage of a signal E2 to the contactor for counterclockwise operation. Thus, the motor operates only clockwise during the forward travel. Signal E1 is removed. As a result, the contactor for clockwise operation returns to the initial position. The motor is dead. The signal E2 for counterclockwise operation can now be fed via P2 and A2 to Z1. The line R is connected to the motor connection W, S is connected to V, and T is connected to U. The motor now operates counterclockwise and the carriage returns. The contactor for counterclockwise operation blocks passage of signal E1. Simultaneous energizing of both contactors, and thus a short circuit, is prevented by this interlocking in the valve. A time lag is produced as a result of the distance between the valve and contactor operating mechanism. A valve and simultaneously a digital timer are actuated. When contact is made in the contactor, the timer is shut off. This time lag is longer when the distance is greater. In addition, the working pressure plays a decisive role. For 1 meter of tubing and an operating pressure of 6 bar, the time lag is 18 milliseconds. For an operating pressure of 2 bar, however, the time lag is 36 milliseconds. With 10 meters of tubing and an operating pressure of 6 bar, the time lag is already 90 milliseconds. In summary, pneumatically operated switches can be designed as normally closed, normally open, or changeover switches. Pneumatically operated contactors save on the switch when actuating electric motors. In a reversing contactor combination, pneumatic interlocking is possible. In this way, simultaneous signaling for clockwise and counterclockwise operation is impossible.